Welcome to Daikin web-based training. In this course, we will learn about the principles of refrigeration. There are three items we will be learning about in this course. The first is heat and heat pumps. The second is heat pumps and air conditioners. And the third is the refrigeration cycle. We will be learning about the mechanism of how air conditioners cool rooms, or in other words, the principles of refrigeration. Be sure to note, however, that while all air conditioners are heat pumps, regardless of whether they are cooling only or cooling heating, in our industry, a heat pump usually refers to a cooling heating system. First, let's learn about heat. As you may well know, the properties of heat dictate that it moves from high temperature areas to low temperature areas. Let's use a familiar situation to explain this. In summer, the outdoor temperature is higher than that of indoors, and the room temperature rises in conjunction with an increase in the outdoor temperature. Because of the properties of heat, heat transfers from the relatively high temperature outdoors to the relatively low temperature indoors. As a result, the room warms up. Conversely, the outdoor temperature is lower than that of indoors during winter, and heat moves from the relatively high temperature indoors to the relatively low temperature outdoors. Resultantly, the room cools down. In other words, the warming up or cooling down of a room involves the transfer of heat. Now, let's think about how we can cool a room in summer. According to the example mentioned previously, the properties of heat dictate that the heat in a room moves to the outdoors during winter, resultantly cooling the room. In other words, if we are able to move the heat in a room to the outdoors against the properties of heat, the room cools down, even during summer. In fact, using a certain device, we can move heat from a relatively low temperature location to a relatively high temperature location. Let's now learn about a certain device that moves heat from a relatively low temperature area to a relatively high temperature area. The transfer of heat is very similar to the manner in which water flows. Water naturally flows from high to low places. Similarly, heat naturally flows from high temperature to low temperature places. And a water pump is a device that mechanically forces water to move from low to high places. There also exists a device, much like a water pump, that mechanically draws heat from a low temperature to high temperature places against the properties of heat. This device is known as a heat pump. The heat pump mentioned earlier can be used to move heat from a relatively low temperature room to the relatively high temperature outdoors during the summer. In other words, an air conditioner is a device that applies this principle. This is a general example of how an air conditioner works. Let's now go briefly into an explanation of an air conditioning system. The equipment installed indoors is called the indoor unit, and the equipment placed outdoors is the outdoor unit. The two are connected by piping. The system moves the heat from the relatively low temperature room to the indoor unit through the piping to the outdoor unit. Using the mechanism of a heat pump, air conditioners can cool rooms. Let's now learn about heat transfer using air conditioners. The role of the indoor unit is to absorb room heat. The indoor unit houses a device called an indoor heat exchanger, within which runs a medium of a temperature lower than the room temperature. Due to the properties of heat, the room heat moves from the relatively high temperature room to the relatively low temperature medium. This is the process of heat absorption. Moreover, the absorbed heat is transferred along with the medium through the piping to the outdoor unit. The low temperature medium used in the air conditioner is referred to as refrigerant. and the piping that links the indoor and outdoor units is referred to as refrigerant piping. Let's now learn about the roles of the outdoor unit. The outdoor unit has two different roles. We will now take a look at the first one, refrigerant temperature rise. The outdoor unit houses a device called a compressor. Much like a pump, it draws the low-temperature refrigerant that has absorbed the room heat using the indoor heat exchanger. It then changes this refrigerant to a temperature higher than the outdoor temperature. This process is referred to as the refrigerant temperature rise. Next, let's learn about heat release, the second role of the outdoor unit. The outdoor unit houses another device called an outdoor heat exchanger. The refrigerant heated by the compressor is sent to the outdoor heat exchanger, where it moves the absorbed room heat outdoors using the properties of heat. This process is referred to as the heat release, and this is the opposite role as that of the indoor heat exchanger. Up until this point, we have learned how air conditioners transfer the room heat outdoors, or in other words, how rooms are cooled. Let's review how this all works now. First, the low-temperature refrigerant in the indoor heat exchanger within the indoor unit absorbs the heat from the room. Next, the temperature of the refrigerant that has absorbed the heat is further increased by the compressor within the outdoor unit. Then, the high-temperature refrigerant in the outdoor heat exchanger releases the heat outdoors. To sum up, rooms are cooled by making use of the properties of heat, namely heat absorption and heat release, as well as the mechanical force to increase the refrigerant temperature. This is how the air conditioner's heat pump works. In reality, there is at least one other device that is essential to an actual air conditioner. This device is called an expansion valve and is usually housed within the outdoor unit. The role of an expansion valve is to change the high-temperature refrigerant that has released heat via the outdoor heat exchanger to a low temperature. This process is referred to as the refrigerant temperature drop. The refrigerant changed to a low temperature by the expansion valve is transported to the indoor heat exchanger via the refrigerant piping, allowing it to absorb the heat in the room once again. This refrigerant flow is referred to as the refrigeration cycle. Let's summarize how the refrigeration cycle works now. First, the low-temperature refrigerant in the indoor heat exchanger absorbs the room heat. Next, the low-temperature refrigerant changes to a higher temperature in the compressor. Then, the high-temperature refrigerant releases the heat outdoors via the outdoor heat exchanger. Up to this point, we have looked at the roles of the heat pump and the temperature status of the refrigerant. Next, the high-temperature refrigerant changes to a low-temperature refrigerant via the expansion valve. The refrigerant returns to the indoor heat exchanger where it absorbs the room heat again. This completes the refrigeration cycle. The devices involved in the refrigeration cycle, their roles and the changes in refrigerant temperature are summarized in this table. The refrigeration cycle mentioned so far is what we call cooling operation, where the room heat is absorbed and then released outdoors. With this refrigeration cycle, heating operation is not possible. However, air conditioners are actually able to heat air during winter. Now, let's take a look at how this is done. Heating operation is opposite to cooling operation, to release heat into the room. In other words, if the air conditioner's outdoor unit is switched, with the indoor unit, heat can be released indoors. However, it is not realistic to switch the location of indoor and outdoor units every summer and winter. A much simpler way of switching the cooling and heating operation is to reverse the refrigeration cycle. To be specific, refrigerant in the outdoor heat exchanger at a temperature lower than outdoors absorbs heat from the outside air. The refrigerant that has absorbed the outdoor heat further increases its temperature within the compressor, raising it higher than the room temperature. The high-temperature refrigerant releases heat into rooms via the indoor heat exchanger. In other words, the heating operation is the reverse of the refrigeration cycle. Be sure to note, however, that while all air conditioners are heat pumps, regardless of whether they are cooling only or cooling heating, in our industry, a heat pump usually refers to a cooling heating system.